What's up, everybody? Okay, I hope you're ready for round 2 of the Tech Track Tech Talks. I'm really excited for this next guest. You know them from Ethereum, and now you'll know them on Celo and a number of other chains soon in the near future. But we have, for your viewing pleasure, we have Nader Dabit from The Graph, who is going to be telling us everything about what the Graph's plans are for Celo. And I'm just so excited to have Nader here. It proves that, once again, crypto is interesting enough to continuously steal FANG developers from the traditional web space. And Nader is just another great example of that. I'll hand it over to you, Nader, and you give the people what they want.
Thank you for that. That's a really, really great introduction. I appreciate it. So yeah, I'm happy to be here. And this is a new space for me. And it's been something that's been interesting me more and more. So I've been here for only a few weeks, but I'm like extremely having like a really good time here. And I'm learning so much. And I'm excited about the technology that I've been able to work with lately. So it's been awesome so far. And today I'm going to be talking about a couple of things, but the main thing that we're going to be doing is kind of looking at how to build a subgraph. And it's kind of a workshop type of presentation that's broken up into 2 parts. The first part is me giving you kind of an introduction to what we're working on at Edge and Node and the graph and what the graph is. And then the workshop portion is going to be us building a subgraph ourselves. And I'm going to be presenting not only like a step-by-step coding tutorial, but I also have an open source GitHub repo that is there for the taking. So if you want to follow along, if you want to build along, as long as you have a computer and a terminal and maybe Node.js installed, you should be able to follow along at the pace that I'm going to be presenting at. If not, the repo is open source, so you can take it, use it at your pleasure whenever you want to. If you ever want to kind of come back to it to learn how to build one of these subgraphs, you can take it from there. So as he introed me, I'm Nader Dabit. I'm a web and mobile developer. I'm an author, and currently I have recently joined Edge and Node as developer relations engineer. One of the main projects that we work with at Edge and Node is the graph, because really Edge and Node was founded by the Graph core team, and that's really what I'm going to be talking about today. And the graph could be kind of like elevator pitched as a global API for DeFi and Web3 data. Often people talk about it as the easiest way to query blockchain data. So if you think about the infrastructure or the architecture of a traditional Web2 app, you typically have this data layer that's a combination of an API endpoint as well as some data source. And this works really well for databases, servers, serverless functions. All of these things kind of are very established in this old school infrastructure that we're used to working with in the Web2 world. But I think what is obvious that is missing in the Web3 world is this data layer. And you're seeing a lot of different approaches to kind of filling this need in ways that people are going about it. But when you look at the traditional ways or different ways that people are querying blockchain data, you very quickly come to the conclusion of a couple of things. First of all, it's very inefficient to query data directly from the blockchain. And therefore, people are coming up with their own centralized solutions often to solve this problem. So they're building out their own indexing servers and they're managing them themselves. And what this kind of does, though, it breaks the core fundamental ideas of what decentralization is. So in order to get around that, or to kind of make this an actual decentralized system, you're seeing different protocols that allow for different ways to interact with this data. And that's what the graph is. The graph is a decentralized protocol for indexing and querying blockchain and IPFS data using GraphQL. And what we're going to be doing today is building a subgraph on top of the Ethereum blockchain. So the graph has been launched since the end of 2020, and it quickly has become a default part of the stack for a lot of different, in a lot of different ways. So if you look at some of the really popular starter projects for building out dApps, like Scaffold ETH, for example, you'll see that it has kind of all these core building blocks. It has the front end, it has the smart contracts, it has the development server, it has the front end client libraries to interact with the chain itself, but it also includes a subgraph. And that's because a lot of people are building out different graphs on top of different data, different smart contracts. Like as of this presentation, there are over 10,000 subgraphs that have been deployed by over 18,000 developers. A lot of these applications you've probably heard of, things like Uniswap, things like Maker and stuff like that. And these 10,000 subgraphs were built by over 18,000 developers. That's because often more than one developer kind of collaborates on a single subgraph. Not only in kind of the Web3 world, but you're kind of also seeing people building apps in the traditional Web2 world. So companies like Forbes, virtual games, and things like that are being built using the graph as the API layer. The volume for the hosted service, which is what we're going to be deploying on today, is kind of like an indicator of some of the growth that's been happening. Over 19 billion queries last month in March, 600 million active daily queries, over 600 million, with an average growth of 20 to 30% month over month. And there are a lot of apps within the DeFi space in particular that are using the graph. A couple of them that you might have heard of, Uniswap and Compound. They allow you to query data not only as it was stored, but you can index it in different ways. So you can aggregate data, you can do time series stuff, you can do full text search, all types of stuff, which is what we're going to kind of look at today, how this indexing works. And this is kind of a general overview of what the API layer might look like for the visualization and graphical part. So for instance, once you've deployed one of your subgraphs, you can test it out in a GUI to kind of get different queried results, so different selection sets of the data that you've indexed. And we're going to be doing this as well. And the graph network, the way that the protocol is kind of works, it allows for different levels of and different types of participation. So you have your indexers, you have your curators, you have your subgraph developers, and they all are doing their own part to kind of build out and make sure the system is working properly. And the way that the mechanism that enforces this is GRT, or the graph tokens. And there are kind of two main ways to secure and receive cash flows in the network. One as an indexer and one as a curator. Indexers are the people running the actual nodes. So they're the ones building out and running the servers. The curators are subgraph developers or just people that want to signal on a subgraph to kind of tell people that this is a valuable API and you should consider indexing it. If you want to learn more, there's a lot more to kind of that goes into this. I would just check out thegraph.com and kind of walk through some of the documentation there around how all this stuff works. But really what we're going to be focusing on today is building an actual subgraph. So I'm going to link to a workshop, an open source workshop that contains two things. It contains a step-by-step guide, and this is the guide that I'm going to be following. We're going to be starting from a brand new empty terminal window, building out our subgraph, deploying it, testing it, and then updating and then redeploying. In addition to that, I've also included the code base for what we're building. So if you ever get stuck and you want to kind of look at the code that I have already been writing and deployed, you can kind of use that to get an understanding of maybe what you maybe have missed. But before we kind of walk through that, let's kind of look at the different steps that are needed to create a subgraph. So first of all, you need to initialize your basic subgraph boilerplate project. And the core of what a subgraph is this this YAML file that kind of defines all the different properties that our subgraph that is made up of. So things like the smart contract address, things like the entities that we'd like to store, as well as our data model and things like that. So first of all, you initialize your subgraph, you define the data sources that you would like to index. So this could be a single or multiple smart contracts. So you can kind of aggregate different smart contracts into a single subgraph. You then define the entities that you would like to index. So you don't have to index everything. You can index whatever you like. You can even combine different data to into your own custom property or your custom entity. You then define the data model in GraphQL, and this often maps to the entities that you would like to index, or it's maybe an aggregation of multiple entities. Once you've done that, you have your business logic, which is kind of how we transform the data that is being stored on chain into our indexer. So this is going to be typically off of some type of event. And an Ethereum smart contract, you might just consider the event itself as a very common way of getting the data off of the chain. And after you've defined your assembly script mappings, which is again kind of your business logic, you then deploy, and then you're able to start testing it out. So that's kind of a mouthful. So let's kind of walk through how this actually works step by step. So to follow along, you can go to github.com/dabbit3, and there's a workshop there called Building a Subgraph. And that's what we're going to now jump to here. And I'll try to zoom in a little bit. And what we're going to be building is an NFT subgraph using Zora's smart contract. So if we go to Zora, we see that we have all these different NFTs. And we can kind of view the NFT, we can view the metadata and such. So what we would like to do is we want to kind of take the smart contract that Zora was built off of and maybe build out our own subgraph using that smart contract data. And that's what we're going to go ahead and do in this workshop. So to follow along, you can just kind of like go step by step here, and we'll go ahead and get started. So the prerequisites for this workshop are that you have Node.js installed on your machine. So if you do not have Node.js installed, one of the ways that I often recommend doing that is by using NVM, which is Node Version Manager. And this is a good way to kind of have a clean installation of Node.js, but also be able to kind of toggle between different versions. So once you have Node installed, we can go ahead and jump to our terminal and we can start building. So I'm going to go into my terminal. And I'm just going to go ahead and remove this subgraph that I built as a test. And we're in a brand new kind of clean project, or a new terminal window, new folder. And let me actually increase my font size, maybe just a tad, to make sure that everyone can see what's going on here. All right, there we go. Okay, so we're in our empty folder, and we're going to now need to go ahead and start getting everything set up. So the way that we're going to initialize a new subgraph is we're going to kind of create this boilerplate using the Graph Cli, and we're going to run graph init with some arguments. But before we do that, we need to go ahead and define our actual subgraph in the Graph console. So to do that, we can go ahead and right under creating the Graph project in the console, we can click on Graph console. And here we're going to create a subgraph called the Zora NFT subgraph. So we're going to kind of walk through all the steps here. So to get started, you're going to need to go ahead and create an account, sign up. And once you're signed up, you can go ahead and start adding your subgraphs. And once you've kind of signed in and created a couple of subgraphs, you'll see all of those subgraphs here in your kind of like terminal, in your console. So for me, I've created a few different subgraphs. I've even created a couple of Zora NFT subgraphs in preparation for this workshop. But now what I want to do is I want to create a brand new subgraph. And to do that, I can click here, add subgraph. And here we're prompted for a few different things. We need to give the subgraph a name. We can have an optional description and GitHub URL, and we also need to give it a title. So you can kind of give it whatever metadata that you like, but I'm going to go ahead and just kind of go along with the workshop material here, using the Zora NFT subgraph as the name. The title is a subgraph for querying NFTs. And I might just leave the description and the GitHub URL blank for now. And I'm just going to click hide, because this is kind of a pretty basic example, and I don't really care for it to show up on the main network. But if you do want this to be available for other people, then you can kind of leave this not hidden, available. So once you've filled out the subgraph name and the subtitle, you can click Create Subgraph. And here you're going to see that you have, your an admin panel type of deal going on, where you kind of have some instructions. But we have yet to create our subgraph, so we can't really do all of this stuff as is. We're going to be building our own custom subgraph. But one thing to keep in mind is that we're going to be needing a combination of the name of our subgraph as well as our account ID or our username. So dabbit3/Zora NFT subgraph, we're going to be kind of using that later. So here in my URL, I have dabbit3/Zora NFT subgraph. So just keep that in mind in just a moment when we're back in our terminal. And then the other thing that you might need in just a moment is this access token. And this is going to be how we authenticate and deploy our subgraph from our local machine. So with those two things in mind, let's go back to the subgraph and continue working. So we've created our subgraph in the hosted UI there. And what we now want to do is go ahead and initialize a local subgraph. And the way that we're going to do that is we're going to first install the Graph Cli using either npm or yarn. So I'm going to go ahead and install this, even though I kind of already have it installed just for demo purposes. So I'm going to say yarn global add or npm install -g at graph protocol/graph CLI. And after you've installed this, now this is extremely fast because probably a combination of me being on an M1 and maybe I've already installed this, so it's really fast. But after you've installed the Graph CLI, you should be able to just run graph and see that you have a binary that is being executed with some information. So we might say graph-help. And now we kind of see a few different commands that we can run. All right, so with that being said, let's go ahead and continue on. So once we have the CLI installed, we can initialize a new subgraph in a couple of different ways. Well, actually, I would say three main ways. One, just running graph init, and then it'll walk you through different steps to kind of fill in each and everything. You can also initialize a subgraph from an example GitHub repo. So if someone has deployed a subgraph that you want to kind of use as a starting point, or maybe if you just want to deploy that yourself to get up and running, you can do from example and just point to the GitHub repo that you want to deploy. And this will go ahead and pull everything down for you, and you can kind of get going pretty easily. The other way is what we're going to be working with is using an existing smart contract. And this is really helpful because the Graph CLI will not only pull down the metadata from the smart contract itself, it'll also pull down the APIs if they're available in Etherscan. And it will also set up a couple of other local configurations for us. And in our case, we're going to be calling index events, which will basically look through the smart contract, and we'll go ahead and set event handlers in our subgraph based on the events that are defined in the smart contract, which is really, really neat and a really easy way, I think, to kind of get started, where you're kind of doing a lot less work. So we're really not going to be writing a ton of code to actually deploy this. In fact, when I first started, I assumed that there was going to be a lot more work than there is, because it's not a ton of work to kind of get this up and running. So, so this is going to be the command that we're going to run. We're going to say graph init. We're going to say from contract, and the contract that we're going to be using is the Zora token contract. So let's go ahead and open that in Etherscan. And here, we have the Zora token or the Zora media contract. And, we have all of the typical Etherscan stuff like the contract, the events and stuff like that. And if you scroll down, you'll notice that there is an ABI here. And this is the ABI that is going to be pulled down for us by the Graph CLI. And we're going to be kind of using that ABI to build our subgraph. We're going to set the network as mainnet. We can also index from other, networks. So we could say we want to index from Ropsten or Kovan or Rikaby or whatever. We're also going to pass in the contract name. And here, this is just going to kind of set the name that we would like to store locally. And here, we're just going to call it token, but this can kind of be up to you how you want to reference this locally. And then again, we're passing index events to go ahead and index those events. All right, so let's go ahead and do that. So I'm going to copy and paste this here. So graph init from contracts, network, mainnet, contract, name, token, and index events. So what it's going to be prompted for now is going to be a combination of our username / our subgraph name. So for me, that's going to be Dabbit3 / Zora NFT subgraph. So I can kind of just copy this right here, or you can like type it in however you'd like. So this will be your username / Zora NFT subgraph. And then for the rest of these options, I can just take the defaults. So the directory Zora NFT subgraph is cool. The network Ethereum mainnet is cool. The contract address, whatever we entered is what we want. And then the contract name, what we set was token. So the CLI is going to now kind of generate all of this boilerplate that we need to kind of get started. And if we now look in our directory, we'll see that we have this new project, this new folder called Zora NFT subgraph. And what we're going to do now is go ahead and open that up in our text editor. All right, so after everything's been deployed or created, I guess you could say, you'll just see that you have some output here that's kind of giving you green check marks that everything went well. And then it kind of gives you some next steps. Graph auth, which is what we're gonna do later, and all this other stuff. We've already changed into the directory and we've opened it in our text editor, and now we can kind of continue along. So let's kind of take a quick look at what the CLI created for us. We have the ABIs that were pulled down for us from Etherscan. So we have the ABI here. We have our subgraph.yaml, and this is where we define all of the different properties of our subgraph. And we're going to walk over a lot of these in just a moment. We also have our SRC folder, which has our mappings. And this is where we kind of write the code that we need to map the events that happen in the smart contract and store them, save them for the indexer, as part of the subgraph. So this is going to be kind of where we save the data that we want to query later. We also have a generated folder, and the generated folder is going to be type-safe types and classes and stuff that are going to be built based on our data model as well as our ABIs. And then finally, we have our schema.graphql, and the schema.graphql holds our data model itself. So there's a lot going on here, but I think we're going to make this pretty easy to understand by removing a lot of this code, because we don't really need a ton of code to kind of build the thing that we want to build. If we go to Zora again, what we might want to do is kind of think about the data that we want. So for me, I think the most important things are going to be things like the metadata associated with the item. So this is going to be like the name of the item and stuff like that. So that might be something like "don't think, just watch," or the title. We also want to get the location of the image or the token itself. So this is going to be some IPFS URL for the most part, where you kind of have this image or this video or whatever stored somewhere. So we want to get that. We also want to get the user metadata. We want to know the user that created this, as well as maybe view any associated tokens that they've created themselves. So we might want to have a relationship between tokens and users and tokens. So kind of this relationship, one-to-many relationship. So thinking about all of that stuff, that's kind of what we need to understand as far as what data we want to retrieve so we can actually index the proper data. So keeping that in mind, let's kind of go down and take another quick look at what's in our subgraph.yaml. And we're going to next, after we kind of look at this, we're going to go ahead and define our data model and our GraphQL schema. But again, looking at the subgraph.yaml, we have a description. This is kind of, not important field, but, it just gives you a description of what it is. We have the repository if we have this open source somewhere and we want to kind of put that there. We have the data source, which is the smart contract address, and we set that when we ran graph inits. And you can see that we already have that kind of set here. We have the address here. We have the start block, which is a way for us to go ahead and tell the indexer where to start looking. So this way you're not going to the very first block. You can kind of tell the subgraph which block to start at. So in our case, we can go to our smart contract address and we can go to Etherscan. And we can go to transactions. We can kind of like look at all the transactions here. And we can go to the last transaction and we can see that the start block is 115.65020. So this is going to be kind of what we use as the start block. We also have the mapping entities. The mapping entities are going to be what we want to save. So what are the different entities that we want to save? Like we mentioned, when we looked at Zora, we might want to save token itself as well as the user. So for us, we're going to have two entities, one for a token and one for a user. We also have the ABIs, which in our case, again, was pulled down from the CLI. And then we have the event handlers, which is going to be where we define which functions we want to fire to handle these events that we're going to be indexing. So with that being said, let's kind of continue on. So what we want to do now is we want to define the entities that we want to work with. So again, we kind of talked about this already. We have a user entity and a token entity. And therefore, in our GraphQL schema, we need to kind of map that into an actual data type. And in our schema, we're going to have a token and we're going to have a user. And to turn a GraphQL type into an actual graph entity, all we need to do is add this @entity directive. And you can kind of see here that we say each type that should be an entity is required to be annotated with an @entity directive. The entities / data that we will be indexing are the token and the user. So let's go ahead and copy this code here and go back into our GraphQL schema. Just go ahead and delete everything that we have there and paste that there. So in GraphQL, we have types, which are kind of like the top level fields, and we have the fields themselves, or I would say the top level entities, and then we have the fields themselves. The fields have different scalar types. So we have like an ID with an ID scalar, a token ID with big int, and we have strings. You also have booleans, things like that in GraphQL. And the exclamation point just means that it's required field. So in this case, we're saying we want the token to have an ID. We want to have a token ID. We want it to have a content URI. So this is going to be kind of like where the actual content lives. We want to have the metadata URI. So we want the information about the content itself, like where does that live? And then we have two fields that refer to another field. We have a creator and we have an owner. And both of these are of type user. So that way we can kind of keep up with who owns this actual token and who was the original creator of the token. And to do that, we also create another field for that entity. I'm sorry, another top level type for that entity, which is called user. And we just kind of refer that here. And then we make a one-to-many relationship between the user and the token by using this additional directive that we are using here called @derived_from. And this way we can just set the field that we want to derive from. So we're saying the token derived from the owner field, token derived from the creator field. And this creates that one-to-many relationship. Okay, so with that being said, we should be able to go ahead and save our GraphQL schema and jump back into our workshop. And we'll continue on. There's a little bit more here around what derived from does. If you want to kind of learn a little bit more about that, you can kind of read through this. This is directly taken from the docs. All right, so what we want to do now is we want to go ahead and generate the code that we need to use in our assembly script mappings, where we're going to be kind of writing the business logic that we need. And the way that we're going to do that is we need to generate the these types and these type safe classes and stuff using the Graph CLI. And the way it's gonna work is it's gonna basically look in our schema.graphql, and it's gonna go ahead and then create in this generated folder a new schema for us that we can then use later on. So the way that we do that is we just go ahead into our CLI, and we should be able to run graph codegen. And if this works as expected, oops, I need to go ahead and change into this directory first. And now we can run graph codegen. And you should see some outputs saying that the types were generated successfully. And if we now go into our schema, we should see that we have two main top-level types, one for a token and one for a user, just like we would expect based off of our GraphQL schema. We have a token and a user. Now we have this TypeScript schema that we can now use in our assembly script in just a moment. And assembly script is very much just like TypeScript if you've ever used that. So I wouldn't be scared if you've never used it before. Pretty easy to pick up. So now that we've kind of generated we've created our GraphQL schema, we've created our generated schema based on that schema, we can now go into our subgraph and start making a few different changes. So the first thing that we want to do here is we want to go ahead and set the entities that we want to work with. Now, this is pretty straightforward because we've already said that the two entities that we want to work with are the token at entity and the user at entity. And this is going to map directly to the entities fields here. So we can just say we want to get rid of all of these. We want a token and we want a user. And that's it. Our entities are now defined, and we can now go to the next step. The next thing we want to do is we want to define the handlers that we want to be working with. So which events do we want to subscribe to, and therefore call some type of handler to use the data coming in from that event. So in our smart contract, a transaction happens, an event is fired, we can now take that data and use it and index it. So the two events that we're interested in are token URI updated and transfer. So token URI updated gets fired when someone creates or updates a token. So when someone creates a new token, this event is fired. When someone updates a token, this is fired. So that way we can use this event to save that data whenever someone creates or updates a token. And this is kind of going to be the core data that we're going to be using for our tokens themselves. And then we also want to handle the transfer of a token from one user to another user. That way we can kind of keep up with who the current owner is. Now, since we passed in index events into our Graph CLI, you'll actually notice that these are already filled out for us. We already have transfer and token URI updated, and you'll notice that we have the proper arguments passed in. So we have the index, the address, and the string, which are arguments that we're gonna be able to handle, and everything's kind of ready to go. So the only thing we really need to do is just delete some code. We want to delete everything except for token URI updated and transfer. So we can kind of like scroll up, and let me plug in my mouse real quick. Yeah. So we can go ahead and scroll up, and we're pretty much done with the exception of maybe one more thing. Since we've defined the address, we can also now define the start block. Like we mentioned earlier, we haven't done that yet. So let's go back to our workshop and just kind of copy the start block, which we looked at earlier in Etherscan. So we set the start block, and now we're telling our graph to start here and then go forward, and you don't have to worry about any of the blocks prior to that. The last thing we need to do before deploying our subgraph is now to write our assembly script mappings. So we can go ahead and open src/mappings, and we can go ahead and maybe just delete all of that stuff. And we're going to go ahead and maybe start from scratch. So the first thing we can go ahead and do is import. We're going to go ahead and import our events. So we have the token URI updated event. We have our transfer event, and then we have our token contract. And then we're going to now also import the schema that was generated for us using Graph Codegen for the token and the user. And we're going to basically be using these for type safety. And the two events that we want to handle One, it's going to be handle token URI updated. So if we go again to our subgraph.yaml, we'll see that we have token URI updated, and then we're calling this handle token URI updated, which in our mappings needs to be kind of defined in the same way. So here we have handle token URI updated. This maps directly to our GraphQL, to our subgraph.yaml handler for handle token URI updated. So the only thing that we're going to do here is we're going to say we want to take the event that's being passed in, and we're going to use the event.params.token ID, and we want to go ahead and load that token. So we're going to basically get a reference to that token and all of the metadata associated with it. We then want to update one field. We want to go ahead and update the token URI, the content URI for the token. And then once we've updated that, we're going to go ahead and save that token. So when this handler gets invoked, it's going to read the token off of the event using the token ID. It's going to update one property, which is the content URI, and then it's going to save it. And then we're kind of ready to go. And that's all we need to do there. So that's a pretty basic function there. This one has a little bit more going on, but let's take a look. This is handle transfer. And what this is basically going to do is going to see if the token exists. It's going to go ahead and update it here. If it does not exist, it's going to go ahead and create it. So this is going to be kind of how we create a token and how we update a token. The way that we're going to do that, again, we're going to look for the event.params.token ID that comes in as an argument here. We're going to say we want to go ahead and create a reference to that token. If the token exists, if the token does not exist, we're going to now go ahead and set all the different properties that we need to on it. So we're going to create the token itself. We're going to set the creator, the token ID. We're going to set the content URI and the metadata URI. And then next, we're going to go ahead and set the owner, because regardless if this is a new token or an existing token, the transfer is going to be transferring ownership to the person that is to. So it's event.params.to. And then we're going to go ahead and save that. And then we're also going to create a user if that user does not yet exist. So this logic is similar to the logic here, where we're saying if there is no user, we want to go ahead and create that user. All right, so that should be it as far as like the code that we need to write for our subgraph. So the main things that we did were we updated our GraphQL schema. We updated our mappings, and we updated our subgraph.yaml. And now we can go ahead and move on to the next step, where we can go ahead and run a build to kind of make sure everything is working. So to do that, we can run graph build. And I believe this will also be done if you run a deployment. So the build automatically should happen if you just deploy. But it looks like everything compiled successfully. So we can now go ahead and go to the next step. And what we want to do now is go ahead and deploy our subgraph. And this is going to be using a combination of our local subgraph as well as the subgraph information that we have in our console here. And what we're going to need is this access token. So I'm going to go ahead and copy this to my clipboard, and we're going to continue on. So to do that, I'm going to run graph auth. We're just going to actually copy all of this here. And then my access token. So I can say graph auth. I can set this URI and then pass in the access token. And if this works properly, we should see that the access token has been set, and we can now go ahead and deploy. And the way that we're going to do that is by running yarn deploy. And this might take a couple of seconds. So let's go ahead and go to the next steps. And once this is deployed, we should be able to go into our subgraph here in the hosted service and kind of refresh and see something like this, where we can kind of start playing around with the API. So let's go to our terminal and we'll wait around for a second. And it looks like it built successfully. So we say we have build completed. we have deploy to, we have our subgraph endpoints. And we should be able to go ahead and test this out. So let's go back here and hit refresh. And here we see that we have our subgraph deployed. And you see that it's already kind of been synced. So that's pretty cool. So we should be able to go ahead and start reading some data from it. So what I'm going to do is I'm going to actually go to the GitHub repo and copy some of these queries that I have here. So we have some pretty basic queries, one for reading just the tokens. And we're going to get the token ID, the content URI, and the metadata URI. So that looks like it's working properly. We can also pass in different arguments and stuff. And in this example, we're passing in an order by and an order direction. So we're going to say we want to order by ID and we want to order in the descending fashion. So now you see that we have ID 999. If we change this to ascending, then we would start at 0. So our sort direction is working properly. We can even skip. So I think the only thing that we're changing here is passing in this argument of skip. So let's go ahead and try that. And this starts at 1088. We remove that, we see it start at 0. And we can also query for users. So we can say we want to get the users, we want to get their ID, and we want to get their tokens. So here we have like this one-to-many relationship where we query for users and their tokens. And we haven't really looked at the content URI, but if we copy the content URI and maybe the metadata URI, we get that as well. So let's say we want to go view that content somewhere. Should be able to go there, and that's what we get. All right, so that seems to be working good. So the next thing we might want to do is, right now we have a couple of different mechanisms to kind of like do sort direction and stuff. But let's say we wanted to add a new feature. And in this case, we might want to query, how do we get our query to look exactly like this? Was kind of my question. I want to show the newest tokens that have been created, and I want them to kind of show up in the same order. So to do that, we might want to be able to query and sort by the date of update or the date of creation. So what we're going to do is we're going to look at the created at timestamp, and we're going to go ahead and redeploy our subgraph and create a query based on that. So to do that, we can go ahead and add a new field to our GraphQL schema. Under token, we're going to add a new field called created at timestamp. So I'm going to go back to my GraphQL schema. I'm going to add a new field called created at timestamp and save that, and we're good to go. And we're going to run graph codegen again because we're going to need that type, that field to be available on that type. And then the last thing we want to do is, in our assembly script, we want to update the handle transfer method to go ahead and add the created at timestamp. And the way that we're going to get this is we're going to be using the event.block.timestamp. So in the past, we've been working off of the event.params. In this case, we're using the event.block.timestamp. So if I go back to my mappings, I can just kind of go right here under a token ID, and we're going to now say token.created at timestamp is equal to event.block.timestamp. And this is going to now add, the created at time, and we should be good to go. So to deploy that, we can redeploy by running yarn deploy again. We shouldn't have to re-authenticate or anything. So we'll give this a second, and then we'll go ahead and test it out as well. All right, so if we go back to our subgraph, we want to now query and order by created at timestamp. So I can go here and refresh. And it looks like we have this pending version here. So this is kind of the version that's being built right now. And it looks like it may have already been synced because we have 4,802 entities. So let's go ahead and try testing it out already. And we're adding this new field created at timestamp, and we can even kind of like maybe return that as well. So if we query, we get that. So what we want to know is like, if we look right now at this metadata content, the content URI, is it going to be that? Because that's what we want to do. We want to build out maybe our own UI or something like that. And we need that same data. So the way we do that, we'll paste that here. And we see that we have the corresponding piece of content there. And if I go to the next one, I should see that it is this piece of art here. So that's it. Everything seems to be working as expected. Now, I know we kind of covered quite a bit, and we talked about a lot of different concepts that might be new to you if you've never used GraphQL. You maybe have never written assembly script. So I would say, if you're interested in learning more about this, I kind of wrote this tutorial to be literally 100,000% foolproof, copy and paste. As long as you have your environment set up with Node.js and you have your Graph account, you should be able to be successful with this. So even if you don't understand everything that's going on, I would recommend going through here, copying and pasting it. Everything will start clicking, and you'll start kind of seeing and realizing maybe the possibilities that are here. So that being said, I want to go ahead and wrap this up. And I want to say thank you so much for checking out this talk or this workshop. And feel free to reach out to us at Edge and Node on Twitter, or the Graph Protocol on Twitter. If you want to participate and do more stuff here, there's a lot of ways to contribute. You can check out our Discord. You can go to our docs, learn more about what's going on. You can go to our website. You can reach out to any of us on social media or anywhere like that. So that's it for me. Thank you for having me. And it was a pleasure being here. And thank you for being my very first talk in the Web3 space. And I'm excited to be here.
Wow, thank you, Nader. That was incredible. And honestly, I know that was your first talk, and you're coming to us to the Web3 space from AWS over at Amazon, but you look like a veteran out there. And that was incredibly well built and incredibly thorough explanation of how to work with the graph. So yeah, thank you for joining us for Kuneco, and you're super excited for all the work the Graph's going to be doing with Celo, and subsequently excited for the work that's going to come out of people who are able to utilize the Graph when they're building on Celo. So
absolutely, we support multiple chains and adding more very often.
You guys are one of the fastest moving teams I've seen in the space, and I think that just is a testament to how necessary what you provide is for us as a community. So thank you so much for showing up here, and you're welcome to the Celo ecosystem. You know.
Thank you. An honor and a pleasure to be here.
Thank you.